Hello everyone. I'm going to start solving today's advent of code soon. Yeah, this is yesterday's code, which the part two part had like a loop of going over 4 million rows and like 30 beacons, 30 sensors, and it did finish up in a reasonable time, but I later thought that the more efficient algorithm would have to go over the diagonals, and each sensor's radius is basically a rectangle. If you look at it in the diagonals, you kind of have to deal with even and odd diagonals separately, but then it's just rectangles, and we can just handle a whole bunch of them together. Yeah, then the complexity becomes something more on the order of the number of sensors, and not the 4 million rows we were processing here yesterday. Anyhow, let's close the code and look at today's question. So, solving yesterday's question, we found the distress signal, and there's a volcano about to erupt, and we have an input like this. Okay. Let's copy the input. Let's split over the lines. Oh, the keycaster thing, I should add it. Okay. Okay, now you should see what I'm clicking. Alright, so we'll split over lines, and yeah, let's extract this big thing and call it advent 16 example input. Right. So let's map over this, and I guess I can just split the words from it. Let's call this line. Line dot split space, and I'll make an array of it. Right. And then let's make a record. Valve is array at 1. Yeah, this is valve AA, has flow rate something. Then there's a rate, which has something to do with, it looks like it's the 4th, or index 4. Yeah, except we have to parse this thing. Oh, I'm away here, sorry. So remove prefix rate equals, and now I don't know if the parse handles it handles the semicolon at the end. It does not. It does not. Which is okay, I suppose. Do we have a remove suffix? Remove. Let's make remove suffix then. Remove suffix. Text suffix. It will be an operator, and we will say, do we have ends with? Okay. let's have the text as bytes, and let's have the length of it. And we are going to also take, well, I guess let's do like this. We'll also take the length of the suffix as text, and as bytes. And well, if the text has to be longer than the suffix, and this is in the way again. And if it is, and slice of the text, all right, slice of the text from num0 minus num1 to num0 is equal, let's make a text of this. If this text is equals to the suffix, then we are returning the text that is the slice of the original text at from 0 to num0 minus num1, and in the other case let's leave this hole in place. So this thing I'm going to do, I'm going to do remove suffix, yes, and now it's parsing, the rate is 0. Now what else do we have in our line? Tunnels lead to valves. Let's add the tunnels field to the record. And let's go from, I don't know, we'll see which word. So let's do, for example, 6 dot dot length of this array, which we can call words. We're going to map over them, and we're going to bring words at this num, which we can call index. And then now lead, it's not lead, it's not vowels, so we're starting at word 9. And yeah, might be nicer to look at as an array of those. So yeah, so we have a record of destination tunnels, and we have that for everything, and then we need to do something with it. All of the valves begin closed. We start at AA. Okay. So it looks like it takes us a minute to go between valve to valve. Okay, this looks like an interesting question. We want to go on a path on this graph. A can go to B and D and I. And and accumulate the most scores, where the scores are by each one has a number which we multiply by the remaining iterations we have. So so in contrast to search algorithms like Dijkstra, it doesn't matter how, let's say we went to this EE. It does matter if we visited DD before or haven't, for example, because we cannot get its reward again the second time. So it's not a classic search problem. Okay, so they're saying instead consider this approach. Yeah, okay. Sorry for the boring live stream. Yesterday, Dan was here and gave me an algorithmic suggestion, so if anyone has an idea, feel free to share it. But I'm a bit stumped at the moment, I just need to think about it. I'm kind of live streaming a coding interview, feels like, You have a puzzle and I need to really think about it this time. It's not, it's not as straightforward as yesterday's part one. So if we do consider exponential stuff, but I don't know how large my example input is going to be, but now there's only 1, 2, 3, 4, 5, 6. Actually, we can count the lines. Let's do this. Advent 16 example input dot split new lines and just count them. There's 10 lines. So we could do like an exponential, consider out of the states of which ones were already visited and which ones weren't. Also, it's not important to count those with the rate equals 0. So that's 4 of them. So it's actually only 6 which we do need to count. And then we could do like a search, like a Dijkstra search with, or BFS search with the nodes multiplied by the different states of what we have or have not visited before. So let's at least start with something naive, as it's a live stream and I don't want to bore you. So also, if I'm doing a code interview, I would prefer seeing something naive than trying to think about like the best solution possible. Yeah, so let's collect all of these into an array. So we're going to, and and I'm going to assume they are sorted. If not, then we'll check it out later. Yeah, so, and put it in a let item. Now I'll remove the annotations to make it more succinct. So what I want to do is try a lot of paths and use the best one I found, basically. So we know we start at A. So let's make the initial state. Current is AA. And let's do it like open valves would be a list with let's make it empty, and then we also have score equals 0. This is our state. And well, we also want to count down how much minutes we have left. So let's say minutes 30. And this will be the initial step. And let's we will look in the array to find this. We're just going to do a linear search first, where valve equals car. And I'm going to assume that this finds something, alright? It has to. So in that I extract a let item. Right. And so score is going to be, or I guess let's call it score. It's going to be score 0 plus. So now it depends if we find, if we already were in this valve before. So actually, let's do open dot any x equals car, and if any is, then it's the same score. But then if not, then we're opening the valve. So we're doing rate times minutes left. This will be the new score. And actually, if we evaluate, we see that it's still 0 because the rate is 0. Okay. And now, if the minutes are over, then we are done. Let's return the score one thing. Otherwise, we'll do a maximum of several options. So, otherwise, let's do a maximum of, are any not leading to anything? Not that we see. Okay. So I'm gonna go over, so first of all, I'm going to assume that there is an answer. We might need something like Rust unwrap, or actually a good UX for that, I don't know. So all of the tunnels I'm going to map over. No, not loop. Sorry, dot map. And then we're actually going to recurse. But before we do it, we may just be going in circles for all of the 30 steps, like after we already opened all the valves, right? So let's first do a condition. If count open is equal to length of the array, then we're also done. Otherwise, this thing. So we're going to go recursively. So basically, I want all of this after the input, or maybe after car. All of this I want to extract it into a function. And let's call this. Let's call the parsed input. Yeah, let's call it parsed. Whatever. So if I extract it, Command X, it. Oh no. Okay, if I don't use parsed here, which is the other variable it's using? Oh, there's len parsed here. So it added it in an unnamed name, which I didn't like, and I want to. Yeah, let's call it input. Let's call it advent 16 recursion. I guess no. Maybe not the best name. Maybe Advent 16. Oh, undo. I deleted the name object, but it didn't appear as deleted. That's another issue to collect. Okay, so Advent 16 search. It needs. Oh yeah. It needs this input, and we'll just repeat this. I don't have a good way to delete the whole let item. Oh, if I delete it from here, I guess. Okay. So we start from AA. Is it capital? Yeah, capital AA. Empty open list. Score of 0 and 30 minutes. Okay. And then yeah, okay. And then from array, what do we do here? We use recursively Advent 16 search. Same input. So now the current is X. So actually, let's not do the score 1 equals thing. Let's do this. Who's using score 1? Oh, I call it score. Let's remove its name. Okay, and we're gonna do this. We're going to return both a new score and a new open. So score is the same if it's already open, and the open are the same. And otherwise it's gonna be score 0 plus X, and then it's going to be, we're just gonna add current to the open. And this is kind of like the next step. So let's actually do this thing here. Let's make a record. We already know that the minutes is going to be, there's going to be one less minute. So minutes is minutes minus 1. And let's use this to extend this previous record. And I'll inline it here. Yeah, so we now have a record of 3 stuff. Cool. Okay. Now if we're out of minutes, well actually even if it's the last minute, there won't be any idea of like going to another place. So actually the answer would be score 1. And actually let's make it into an or count open 1, the new open, equals length of input. Yeah, then we're done. So we don't need this condition here, right? Else we look for all the others. So minutes 1, score 1. I guess it is silly to have minutes 1 here. because we're only really using it here. So let's undo. Let's not have this minutes field. Ooh, red cursor bug. Like it didn't go. To a sensible place when I deleted the minutes thing. Anyhow, so this should be minutes minus 1. And the score is score 1. And the current is this x, and open is open 1. And we have the whole recursion. So this is the silly version, inefficient version of this, and well. Okay, so let's see if it is fast enough for the example. Oh, it reached a hole. So, no. Okay, so we parsed the tunnels things with the comma, with separating them, so our parsing is not good. So let's see. Actually, we can extract this function to advent 16 parse, I guess, right? So let's make this thing. Let's call it 16 example input, and we call it advent 16 parse, and and extract it out here. And we just like, it says dd comma. So the tunnels thing is incorrect, like it's incorrect. Let's take the first 2 bytes of each of these. So dot text, and we'll do a slice of it from 0 to 2, and we will make it into text again. So now we have proper destinations, and now it's running for longer, but it's very, very inefficient. So even this in the example input, it just takes it forever, So we can check alt down, score 580 after visiting DD. So we try DD, and that has 20, and then let's 580. And okay, so what can I tell you? It's just terribly. Oh, did I close the repo? Oops. Oh, I did not. I'm confused. So we did something, but it is terribly inefficient. So we should still think about, is there a trick here we can use? We can prune our search if we kind of know that like the ideal best limit to the score could be doing this one at the first iteration, and then this one, and this, and then the other. And we know how much score we can get. We know how much score we have and how much score we can still get. Well, we don't know that we can get that big score. But once we have found a certain score, we can prune searches according to not possibly being able to surpass that score. Oh, opening a valve also takes a minute. So either moving or opening takes a minute. So I did it wrong. But it's even more options. Because then we can go through a valve and not open it. Oh my god. So let's see. I did it wrong. Opening a valve takes a minute, but then we either open it so actually if minutes equals 1, anything we're going to do is going to take time. So we start with this. And yeah, in this case, and I need to rethink that one. And let's can we move rec 0 here? Yeah, okay. So yeah, if the minutes are 1, we don't need to check anything. Right, now we have this record of the current valve. Oh, actually, sorry, if minutes equals 0 or all of the valves are opened. And maybe it's actually better to start with, instead of having the open valves, keeping track of the closed valves, because then the linear search layer will be, well, doesn't matter. Let's do count open equals actually, I guess we could, when we open the last valve, we will make this condition, not here. Okay, so minutes are more than one, and we have the current valve, and we have options to go to all of the tunnels it leads to, and with the same score we have, because we're not opening a valve this time, and with the same open valves we had. That's, yeah. And it would take us a minute to go to each one. And if we're not open, then we have another option. So let's call these, okay, let's call it list, but let's do an if. Yeah. And if or maybe not an if. So we're gonna check if the valve is open. So yeah, let's do it as an if. If open any of x equals car. So it's already open and list is all the options. Otherwise we have another option. So we'll add that option to the list. And the option is, so it's the same input. Also minutes minus 1 because it's minutes. Because it's gonna take us a minute to open this valve. And we're in the same current place. And open has a new, sorry, not score, open has a new one, which is the current. It's considered open. And the score will be score plus what? Plus the, you know, let's also do each one had a rate. It's not worth opening if the rate is 0. So let's do an AND, but let's put this check on the right side. Command right? No? Command right. Could this work as command right? Okay. Can we have something to work out here with logical operators with the deferred computations? So if rate, rec dot, no, rec1, I meant this rec dot rate is bigger than 0. Or, I mean, not bigger than 0, is 0, then it's not worth opening the valve, even if it's not open. Or I guess We also want to finish if all the valves are open, right? So let's actually make the open thing part of the state of, yeah. So let's just change the rate to 0 once we open it in the input. No. No, let's just do like add another parameter of to open and add it, and then to open will be count. Will filter from the array which we've did from array where rate is bigger than 0, right? That's how much we have to open. And oh, as we added it, it also added it recursively here, which is cool. So this would be the same to open, but if we actually opened it, then we have to open -1, right? Also, if minutes equals 1 or to open equals 0, we can stop. Okay. So then how much is the score changing if we do open? So we're going to add minutes -1 is the amount of minutes the valve is going to be open times the rate rec dot rate. Yeah. And I don't know, let's let it run, and maybe let's also view some running. I don't know why this record is not being expanded. Maybe because it has fields with the same names as the parameters. I don't know. So we see the first time why didn't it reach the condition? It didn't reach a hole. Oh, and it did, oh okay, it did recursively did more calls. Where did it call them? So it got here, oh it got to this, okay, it got to this list. Let's do this, sorry. Well, I guess it always needs to check the first item in the list. So it evaluates the first item in the list before it evaluates the rest. And oh my god. It goes back and forth recursively without even considering to open anything. And it's consuming all the time. So how do I prune that? Basically, we shouldn't be going in circles without opening anything. That's not worth our time. So I reordered the repos by mistake when I browsed the. So it's the same key to reorder them and to browse over the scopes. I don't know. I'm confused. Alt up. Yeah, brings this up. It's also morning for me when I never code well, I think. So let's try. Let's try another one called bean here, which I'm implying bean here without opening valves. So I'll also add a condition here, or bean here dot any is equal to x equals to current. Then we're not going to explore this option anymore. No, actually let's filter from the destination instead of doing it here, sorry. Okay, so this is bin here. It's going to be empty. Once I open the valve, then, or not empty, I'm also going to say there's no reason to return to this one without the opening valves in the middle. Okay, so it's going to be this. But now the destinations, so now the destinations we want to filter from them the one we've been to without opening any valves. Dot filter so from being here, none of them is this x. x0 is not x1. We haven't been here. Then we're gonna go there. So let's add it to that bin here as well, I think. So now at least we won't be going in circles. Bin here is empty and okay. It's probably still going to be super slow because this one maybe does require algorithmic insight to it. But even if this stream hasn't been a demonstration of actually solving the advent of code, at least demonstrate how to try to solve it using Lamdu. Score, okay. We do have some places where we did try opening stuff, which is at least nice. But I guess after I wake up better, I will think about the algorithm here, unless I see some spoilers that spoil it for me. and then I'll figure out how to solve it. And I'll declare this stream at least showing how to use Lamdu to try misinformed solutions, exponential complexity, for today's advent of code. So I think this one, number 16, has been the most difficult one to get, I guess. So I'll stop the stream here, and I will try to come back to it later. Probably not in the live stream, but if I do, then I will share the code in Lamdu, in maybe the Lamdu subreddit. So that will be it for today. I'm not sure when I'll do it tomorrow, whether I'll go to a trip. But we'll find time, if not streaming it, at least to try to solve all this year's Advent of Code questions in Lamdu. So until next time,